What do these companies have in common? Any idea? What's that?
They have users.
Well, they do have users. They have a lot of users. These are the top 20 data breaches from 2018. And out of those companies, more than 1 billion accounts were compromised, including usernames, passwords, credit card information, you name it. And 80% of that was due to stolen credentials of some kind. Now, this is 2018. I haven't updated it for 2019 yet, but it's worse. So those were the data breaches that were publicized, either due to regulatory requirements or whatever, but those are ones that were made public. But there's a company called 4IQ. They're an analyst consultancy company. And they take a different approach to the whole compromised identity problem. They actually troll the dark web and find out what's for sale. Okay? So they keep track of every time somebody dumps a new collection of usernames and passwords or email addresses or whatever. They keep track of every one of those dumps. They count them up, figure out how many are unique, and from that derive some numbers as to how many credentials are actually being stolen and sold. And their numbers are a little bit different. In 2018, they came up with 12,000 distinct data breaches with 3.5 roughly billion user accounts that were compromised. And in the total scope of what's available on the dark web, there are more than 14 billion. That number's gone way up now too. 14 billion accounts with usernames, passwords, and other user specific information available on the dark web. And when you think about that, that's way more than the number of people on the planet. So that means on average, everybody's had at least 3 or 4 of their accounts compromised and stored on the web someplace. It's a ridiculous problem. This one was from late last year in the Guardian, and it's mind-blowing. It's mind-blowing because essentially usernames, passwords, and biometric information was compromised in the UK for over 1 million people. It was just left in the public, and hackers were able to download it. And the company 4IQ again, in 2019, so I got this late last year, there was a 71% increase in available usernames and passwords on the dark web. So that 14 billion number is now 20 some odd billion. And of the breaches from last year, there was a huge increase in government agencies, primarily state and local governments. So this problem is just, it just gets worse. And just when you thought it couldn't get worse, so how many of you have ever been sitting on a Skype call or some sort of web conference call, and you've been typing away doing something else, and you log into an application while you're doing that, you're just listening, sort of lurking in the background on the conference call? Well, it's actually possible to detect the keys that you're typing on the keyboard through the microphone, through the voice over IP call, if you're not muted. This is a paper that just came out, I don't know, a few months ago. I read it from some guys at the University of Padua in Italy. And they were able to recognize passwords with 90% accuracy by picking up the sound from your keyboard going through the microphone on a voice over IP call. So now we've got a whole new way that we can get your password information. And of course, we know how much users love passwords. So if there's if anybody can come up with a reason why passwords are awesome, please let me know, because I can't think of it. But passwords are fundamentally a problem. There's almost nothing good about them. I mean, people pick bad passwords, they write them down someplace, they use them in multiple places. They use very predictable password patterns to come up with passwords. And even at the application level, we have to store those passwords someplace in some form, either a hash or the actual, an encrypted password or something. But they've got to be stored someplace. And if you store them someplace, that means they can be stolen. So passwords are fundamentally evil and we need to get rid of them. And what about two-factor, you say? Well, that's better, but it's still pretty bad. And I'm definitely not saying don't deploy multi-factor authentication, because you should. It's a substantial improvement over regular passwords. But they're phishable, they're expensive, they're hard to manage, and they're also very hackable. So in 2019, there was a set of tools that was made public, Morena and NetPro browser. So it's essentially an HTTP proxy that monitors web activity. It's a way of staging a man-in-the-middle attack. And it's designed specifically to phish 2FA authentication traffic. And then NetPro browser is an automation tool. So it takes all the information that Morena has gathered as a proxy and automates it and starts essentially stealing sessions and credentials from people, even if you're using multi-factor authentication. So multi-factor is very hackable as well, and it's been automated. So instead of somebody sitting there at the keyboard trying to sort it all out, it's now possible to just set up a bunch of bots and have them monitor traffic and hack your 2FA. So not a great answer either. So this is sort of the motivation and the reason for a technology called FIDO. So how many here have heard of FIDO? Oh, excellent. Everybody's heard of it. FIDO2 is a relatively new development. It was ratified last March, I think. And it is a new way to do authentication that doesn't use passwords. So it leverages PKI technology. And in effect, you end up with a device, an authenticator. Here's an example of one right here. That acts as a certificate authority. And it mints public-private key pairs for each website that you have credentials. So instead of using a password as a credential, it uses a PKI key pair. They're really simple to use from a user perspective. You know, you can imagine giving a user the keys to a certificate authority is a bad idea, but they're just tremendously simple to use. You plug it in and you answer the prompt on the screen, and that's how you use it. So the whole process of generating keys and using them to authenticate is incredibly simple, simpler than your normal multi-factor authentication flow. And this is a combination of two efforts that have been going on for several years. FIDO Alliance has been around for probably 6 years, I think, something like that. And they developed this technology for embedding the ability to generate certificates on a small device and using that for credentials. The W3C, who basically develop and standardize all of the web protocols, like HTTP, came up with a new standard called WebAuthn. And it's actually a set of JavaScript interfaces that are built into browsers now. So they standardized all of that. And the combination of the two technologies allow you to do strong, passwordless, almost unhackable authentication into web applications. And that's what FIDO2 is all about. So these are the bits that factor into FIDO2. If you look over on the right there, we have an application web server, or it could be an IDP for single sign-on of some sort. It presents a web page to the user. The browser displays that web page. And within that login form, which would be part of the HTML, there's JavaScript that actually interacts with the operating system and will prompt a user for an authentication device. And there's sort of two pieces to this. There's the registration flow where the user takes their device and registers it with the application, and then there's the actual authentication flow, and I'll show you how that all works. The JavaScript then interacts with the operating system to generate a key pair, and it can do that using either the onboard TPM, if you have such a thing on your laptop or your desktop, or it can use an external device, and even your phone, which I haven't made to work yet, but it's supposed to work. The magic in this whole thing is the fact that because we're using a public-private key pair, the private key lives on the device and never comes off of the device. And it's the public key that the application actually stores as the credential. Okay, so there's never a password that can be stolen, right? I mean, it would be possible for a hacker to steal the public key, but it's not by itself useful, right? You'd need the private key, and the private key lives on this thing, or it lives on your TPM, and it's essentially not extractable. There's no way to get to it. So it's very, very secure and very easy to use. And developing applications to take advantage of it is also very simple. So any questions so far? Yeah.
You said you haven't tried it on your smartphone.
Yep.
When do you plan?
I was in the process of doing that last week, so I'm in the middle of it. And I'll be happy to let you know how that goes.
Do you think that's viable?
Certainly from a technical standpoint it's viable. From an overall security and management standpoint, I think, yeah, I think so.
Any comment about Android versus iPhone?
No, not at this point.
Thank you, sir.
Sure.
How about form factor on the device itself instead of USB, an older version of USB, something newer?
So the form factors that I know have been developed are USB keys of various sorts. So this one has a thumbprint sensor on it. I've got another one here which just fits into USB, and it has a contact on it, so you can verify that a user is present. I know you can use phones using either Bluetooth or NFC, and the protocols are written in a way that they're hardware independent, so there'd be no reason why you couldn't invent other things. Like in Windows 10 Pro, there's Windows Hello, so you can actually log in with your facial recognition. That's actually based on FIDO. Okay. So from a form factor standpoint, I think it's very extensible, and it's just going to be a matter of people coming up with interesting use cases for that. So some terms and concepts, so I can explain this a little bit more in more detail. An authenticator is the gizmo that actually acts as the CA. It generates the key pairs and stores the key pairs. And it can be either a roaming authenticator, like these USB keys are, or it can be a local or fixed authenticator, which lives inside your machine. So like my laptop has a TPM built into it, so does my desktop at home. Most modern laptops do. Most older desktops don't, so it kind of depends. And in the standards, FIDO actually distinguishes between those. So an application can say, I'll accept authentication with a roaming authenticator, but I won't from a built-in authenticator, or vice versa. Those are things that the application developer has some control over. Attestation is the packet of information that the authenticator sends to the application when you register. And it actually includes a certificate that allows you to chase a certificate chain back to the manufacturer. So you can verify that that is a device that you are willing to trust. Now the interesting thing, and one of the features of FIDO, is that you can't correlate identities across applications. So there's not a single unique identifier that you use in multiple applications that you could then later correlate to figure out that this guy logged in over here and then same guy logged in over here. Every credential is unique, but the authenticator model, so the manufacturing model, is actually represented by a single certificate. So you know enough information as an application developer to say, I'm willing to trust that because I trust the manufacturer, and I trust that model, and I know that we've issued these to our users, but there's no unique bit of information in each credential that would allow you to correlate activity across multiple applications, and that's really, really important from a privacy standpoint. An assertion is kind of what you'd think. It's essentially it amounts to a certificate that is sent from the authenticator to the application to represent an authentication process. Okay, and then the application can use it to verify that, in fact, the device that was used to authenticate is the one that generated the public key that it has a record of, that it received during the attestation process. Relying party is essentially just the application that needs the authentication process. And the relying party ID is something that's used to distinguish credentials between multiple applications. And it's essentially the URL of the application. Okay, so that's how you distinguish a credential from one application to the next. And then two other concepts which are really interesting in FIDO is the idea of requiring either user presence or user verification. So you can just say, if the guy sticks his key in there and we extract we respond to the challenge with the properly decoded challenge result because it has the correct private key, we'll say that's good. He has the device, therefore he's authenticated. But you can also require a test, as an application developer, you can require a test that verifies that there's actually a physical user present. So you have to touch something is the usual approach, or with a camera you can verify that there's a face, a warm face in front of it. Or you can also require, beyond just user presence, user verification. And in that case, the user has to present essentially another factor. And usually that's a biometric. So it can be like a fingerprint on this thing, or it can be a facial scan like I have on my laptop using Windows Hello. Depending on the sensitivity of your application, you can require either one of those or neither of them. Okay, that's up to you from a policy standpoint. So the registration flow works like this. You go to your application, you put in a username, and the thing will say, we don't recognize that username, do you want to register with your FIDO device? And at that point, you put your FIDO device in, and it will then mint a new key pair, pass the public key back to the application, store the private key along with the relying party ID on the device itself, and you're now registered. So you have a username and you have a credential in the application. When you go through the authentication process, it's almost the same thing. You go to a login prompt, you put in your username, the application knows that you've registered a FIDO device, and it says insert your FIDO device, and it has enough information to say which one it is. So if you have multiple of them, you can say which one you want. You put that in. If the application requires user presence or user verification, it actually puts that information into the request to the device itself. The browser pops up a window that says, you know, touch the fingerprint reader or touch the device to make sure that you're present. It then decrypts the challenge that came from the application, sends the result back to the application verifies it, and if everything's cool, then you're authenticated. And at no point is there ever a password or a password hash or anything like that being sent back and forth. So there's no useful information you can intercept with a man-in-the-middle attack. There's nothing you can phish by driving the user interface. It's very, very secure that way. All right, let me fire up a demo here. Before I do that, any questions about what I've covered so far? Yes?
What if you lose your device?
That's a good question. And let me get to that after I do the demo, but that's an important question to ask. Any other questions? Yeah.
How do you audit that? If you were looking at encryption keys and look at the footprints, the digital footprint to go back and diagnose a problem potentially, how would you go back and diagnose that issue? If there's two separate keys and authentication happens online, how would you do that?
So I think I don't understand the scenario exactly.
Okay, so let's say I lose my key, for example,
Yeah.
right? And if I wanted to audit that person, they lost their key multiple times, for example, and I want to go and audit them, right, from a security standpoint.
I understand.
How would you do the audit trail? How would you find the audit trail for the signature key?
So typically, if the key requires a biometric or some sort of user verification, the key is essentially useless to anybody.
Hand off, whatever.
Yeah. Yeah, well, you could do that, I suppose.
Right? Chop his thumb off, whatever.
Yeah, right. But generally speaking, it's pretty useless by itself. In the case where the key, so essentially the user would no longer be able to authenticate to any of the applications for which he has credentials. And he would have to then go re-register. And to do that, you get a new key, and you just re-register for those applications.
What about the administrator or the owner of the system or systems?
Mm-hmm.
How would he or she diagnose what the issue was? If it was just an accidental loss, right? Is there a way to reinstate that person automatically, or is it just the registration process that
It's just the registration process. So one of the probably an important thing that I didn't mention about the model of FIDO is that it's a user-driven process. It's not a corporate process where the company buys and logs and distributes a bunch of keys like you do with multi-factor typically. You know, there's no serial number or anything like that. So if a user loses his key, he goes to Amazon and buys a new one. Okay, that's sort of the model. So it's very user-driven that way.
I think most companies would know that you do that potentially.
Yeah, they would want to give out the appropriate keys to everybody, but there's nothing about this key that makes it uniquely trackable. Okay.
Another problem is as well.
It's a problem or it's a benefit, okay? Because from a privacy standpoint, there's no way to correlate them, and that's in fact the driving principle behind that. Okay, give me a second here and let me just get this demo going. Okay, here we go. So this is a demo app that I downloaded off of GitHub, I think, and I made some changes to it. But it's essentially code that you can download and give to your app developers to work with if you want to do that. So the first thing I want to do is show how you would use FIDO as essentially multi-factor, a second factor. So I'm going to create an account here. I'm just going to put in my name, display name, and I'll have a password. Actually, and what I'm going to do here is I'm going to use the local TPM authenticator that's on my laptop. So instead of using this USB device, I'll just use that. So now it's actually prompting me to put my face in front of the camera, and it will take a biometric of my face. So it's recognized me. That's Windows doing that. And now I've registered that. So essentially what's happened is I've created a new public-private key pair. The private key is sitting on the TPM on my device. This application that I'm running on my desktop has the public key. And it's associated with that username and that display name. So if I want to sign in, I'll put in my password. So it's checked the password. Now it's going to verify the second factor. And now I've logged in. So I've used FIDO as a 2FA. Now that's not by itself terribly interesting because we have multi-factor authentication already today. But again, there's nothing that's phishable out of this. So there's no way to get in the middle of this transaction and grab the credentials. So let's try a passwordless approach. Oops. So I'm going to go through the registration process again. I'll put in a username, display name. And now this time, I'm not going to use Windows Hello. I'm going to use this device here. So I'll cancel out of that. Now it says touch my security key. Now you can't see this, but the security key actually has a little blue light that's flashing on it. And so it's recognized the fingerprint. It's generated a new key pair for this website, given the public key to the application where it stored it in memory in this case, and stored the private key locally on the device. So we'll go through the sign-in process. Now, it knows that I used a security key, so it's not prompting me for Windows Hello. And now I've logged in by touching the device. So that all works fine. And you can even, I don't know how much sense this actually makes, but you can actually do usernameless and passwordless. So you can just walk up to the device, plug your thing in, touch it if you need to, and log in that way. It's a shortened flow. Oh, hang on, I need to do this. Okay, so I've just essentially I've registered this key. It's generated a key pair, and the application will now recognize me simply by this device without any username or password. So there you go. So that's how the flow works. It's very easy for users to figure out. All of the major browsers now, Edge, Chrome, Brave. Oh, let me stop a second. How many people have heard of the Brave browser? Brave? So Brave was developed by the guy who originally started Mozilla. Uses the Chromium engine, the rendering engine. But it's built along the ideas of being very secure and very privacy focused. It's free, in my mind, runs faster than Chrome, and it essentially will track and stop all of the mysterious marketing cookies that you tend to get when you're browsing the web. And it also has a built-in Tor browser if you're into that. So I definitely recommend you check that out. So that was just an aside.
I've been using it since August. You bring up a new window, it tells you how much time you saved and how many ads it's blocked. So I just brought it up and it says that it has blocked 237,647 ads and trackers. We've done 872 HTTPS upgrades and estimated time saved is 3.3 hours. So it rocks. It works with everything.
Yep. Okay, let me just.
What happens if you lose your token?
Yeah, so that's a good question, and I think you asked that earlier, right? Let me just get back to my. No, that's not it. What did I do? Hold on a second. Let me just get that PowerPoint up again, and then. Okay, so what do you do if you lose your device? So let's leave a phone out of the question for right now. If I lose this thing, essentially you go through a re-registration process. So I go get a new key from wherever I get them from, and I go back to the websites, and I then have to, I have two choices. One is I can create a new account that's completely divorced from my old account. Sometimes that's appropriate, but most of the time it's not. And I now want to be able to associate my new credential with my old account. And the application developer will have to write some sort of a flow, and you'll have to have some sort of policy for doing that. So the usual approach is you would do an external email authentication to allow that to happen. So you go to the login page, you say, I've lost my device, send me an email, sends you an email. You go through the authentication process and register your new credential that way. So it's a separate flow. But again, it can be entirely user-driven. And the hassle, of course, is that if you lose a key and it's got 100 website credentials on it, you've got 100 websites you have to do that with. That's kind of miserable. That's probably the downside to this model, where you have uncorrelatable identities with every single application that are completely distinct. You basically have to re-register.
I got two questions based on that.
Yeah.
One is kind of the retirement of the user, like the HR process. If somebody's getting terminated for whatever reason, they're retiring, getting let go.
Yeah.
How do they actually trigger that to revoke that key as well?
Okay. So the question is, how do you handle the leaver process? How do you revoke credentials? Essentially, you just remove the credentials from the application identity store. Just like disabling an account in AD, that's essentially it. So even though he has the credential, it's not usable with that application. So that process is pretty much unchanged. And there's no need to recover this key, because if you've revoked the credentials in the, Jesus, sorry about that. If you've revoked the credentials in the applications, then the keys by themselves are not useful. Also, from an administration standpoint, there's nothing you can do with these keys other than reset them to factory settings. So the vendor has an application, you plug the key in, and essentially resets it to empty. And you start all over again. So if there's some reason you want to do that, but you can't inspect the key to see what credentials are on it or what websites have been registered.
Is there any latency between AD and the app that actually revokes it?
So the question is there any latency between AD and the app that revokes it? So this isn't really related to AD per se, and in fact, I've been wondering about how we might integrate this with Active Directory authentication. Now, this is supported by Azure Active Directory, so you can use these now. But for on-prem Active Directory authentication, there's no direct support for that other than in Windows Hello. So there's no, yeah, Sean?
I was just thinking, you could, since it's supported by Azure Active Directory, do something like Azure App Proxy, and can integrate your on-premises app with that proxy, do the flow through Azure Active Directory, do the 2FA and FIDO, and then into the app from there.
Yeah, that would be a way to do it. You said you had another question, or did we cover it?
You covered, I guess, most of it. Things are just popping up in my
Sure.
head as we go along. Now, when you're using a device like this, can you lock it down to an actual system, or is it basically if I steal that device and that before you revoke it, I can pretty much go to any system and plug it in my environment and have access?
Okay, so the question is, can you lock this down to a particular system? So one approach would be, don't use a roaming. If your policy or your desire is to not have people use different machines, then have them authenticate with a machine with a fixed TPM in it, rather than a USB key, because these are designed to be portable. That's sort of the whole intention. So you would lock down, you'd basically, in the registration request that the application sends, says it has to be a fixed local authenticator, not a portable authenticator. And that would be the way to do that. If you wanted to lock this particular USB key specifically to a particular machine, that's something you'd have to do in the application itself. You'd have to write the code to enforce that. Other questions?
How are those affected by when my organization locks down a USB?
Oh, locks.
To open that back up?
So the question is, if you actually have disabled USB ports on your machines in the office, how would this work? So you wouldn't use this probably. The two ways I can think of, one is again using a local authenticator that's built into the machine, but you'd have to have the hardware support for that. It would have to be a relatively modern desktop or laptop. The other way would be to use mobile phone. And like I said, I haven't made that work yet. but I understand it's workable. I've heard people have made it work. And the idea there would be that when you register your credentials with an application, you actually pair your phone either through NFC or Bluetooth with the desktop that you're using, and the credentials are stored on the phone. That might not be what you want to do, though. I mean, if you're sufficiently security concerned that you're going to put epoxy in all the USB ports, maybe people using their own personal phones is not what you want to do. Yeah, I don't know. But those would be the two approaches that I can think of offhand.
Can you have a phone as a primary and a key as a backup?
Say that again, please.
Can you have a phone as a primary and then back it up with a
So the question is, can you have the phone as a primary?
phone? So in case something happens to the phone,
Yeah.
you can quickly grab the key and continue doing what you need to do.
Yeah, so the question is, can you use the phone for your primary credentials and then maybe you use a USB key for a backup? It's certainly not defined in the standard that way because of the fact that there's a unique private key for every registration. There's no way to copy those private keys between devices or anything like that. So it wouldn't be a backup. There's no way to back this up. Okay?
Not the backup, but just to have a secondary in case
You-
something does happen to your phone.
So as a secondary set of credentials, you could definitely do that. The application would have to support it. It would say, register your phone, and you go through that exercise, and then it might say, do you want to have a backup set of credentials, insert a key, and then register those, and it would allow you to authenticate using either credential. That would be the way to do it, I think.
Do you know any organizations that currently use this actively?
I know that Microsoft is using it. Other organizations, I'd actually have to go to the FIDO Alliance website. There are hundreds that are using them in production. It's been around for quite a while. FIDO2 by itself, though, is fairly new. Is there a question? Yeah.
Yeah, I've got two quick questions. You said if the account is disabled or locked, it's won't work, right?
Right.
Okay, and what is the cost or how expensive is it?
How expensive are these? It varies quite a bit. So the cheapest ones, which just detect user presence, like this little guy here, it costs about, I don't know, 15, 20 bucks quantity one. Large quantities probably down in the $9 or $10 range, something like that. These guys, list price with a biometric sensor on it, are about 50 bucks. Quantity one, I imagine half that roughly when you buy in larger quantities. And by the way, I want to give a shout out to EWBM. They're the manufacturer of these things that I've been using here. It's a Korean company that are making a push in the US. They've been super helpful to me for both supplying these keys so I could do demos and also helping me with technical problems. If any of you are interested in trying this out, just to see how it works and see if it's something that's suitable, I can hook you up with Andrew June. He's the local US guy. Super helpful guy. Really appreciate all the help he's been giving me, so just let me know. What's that?
What was the brand?
EWBM. It's a Korean electronics manufacturer. They make a lot of biometric sensors and video sensors, and they make these FIDO2 keys. Yeah?
Do you know if they have been certified by the Department of Homeland?
Have they been certified by the Department of Homeland Security? I don't know the answer to that. I'm sorry? I don't know the answer to that. Andrew certainly would know, and again, if I can ask him or if you want me to connect you up, I'm happy to do that too.